An analogy for 1.2 calories per square centimeter incident energy is equivalent to standing in a sunny park on a clear summer day for about 1 minute without sunscreen. When comparing 8 calories per square centimeter and 40 calories per square centimeter incident energy using the microwave analogy, 8 calories per square centimeter is equivalent to standing in a large microwave for 30 seconds at full power. 40 calories per square centimeter is equivalent to standing in the same microwave for 2 minutes at full power. Other analogies can also be useful. 8 calories per square centimeter is similar to the energy received from a strong sunburn that causes blistering. 40 calories per square centimeter is comparable to the heat exposure from a house fire or a close-range explosion. Explaining the difference, 8 calories per square centimeter can cause second-degree burns, requiring medical treatment, while 40 calories per square centimeter can cause third-degree burns, leading to severe tissue damage and potentially life-threatening injuries. It is important to remember that these analogies are approximate and not meant to be precise scientific comparisons. The actual injury severity can vary depending on factors such as exposure time, distance from the arc flash, and the type of clothing worn. Incident energy is a measure of the heat energy generated during an arc flash event at a specific distance. It is typically expressed in calories per square centimeter or joules per square centimeter, where 1 calorie per square centimeter is equal to 4.184 joules per square centimeter. Arc flash is a dangerous electrical phenomenon that occurs when an unintended electrical discharge travels through the air between conductors or between a conductor and a ground. This discharge produces intense heat, bright light, pressure waves, and loud noise. The severity of an arc flash incident is determined by several factors, including the available fault current, the system voltage, the distance from the arc, and the duration of the arc flash. Incident energy is one of the key parameters used to assess the potential hazards associated with an arc flash. The higher the incident energy, the greater the potential for burn injuries and other related damages. Personal protective equipment, or PPE, is rated based on its ability to withstand specific levels of incident energy. This rating is expressed in calories per square centimeter and indicates the maximum incident energy level that the PPE can protect against. Understanding incident energy is crucial for selecting appropriate PPE and implementing effective safety measures to protect workers from arc flash hazards. Incident energy calculations are typically performed as part of an arc flash risk assessment, which helps identify potential hazards and determine the appropriate safety measures needed to mitigate the risks. Several methods and software tools are available for performing incident energy calculations, including those based on standards such as IEE 1584 and NFPA 70. These calculations consider various factors, such as the system voltage, fault current, clearing time of overcurrent protective devices, and working distance. The results of the incident energy calculations are then used to determine the appropriate arc flash PPE category and other safety precautions required for specific tasks. Reducing incident energy levels is a key strategy for minimizing arc flash hazards. This can be achieved through various means, such as reducing the available fault current, decreasing the clearing time of overcurrent protective devices, increasing the working distance, and implementing engineering controls. Current limiting fuses and circuit breakers can be used to reduce the magnitude and duration of fault currents, thereby lowering incident energy levels. Zone selective interlocking is a protective relaying scheme that allows overcurrent protective devices to communicate with each other and coordinate their tripping times. This can help reduce the clearing time of faults and lower incident energy levels. Remote racking systems allow operators to remotely operate circuit breakers and other electrical equipment from a safe distance, reducing their exposure to arc flash hazards. Arc-resistant switchgear is designed to contain and redirect the energy released during an arc flash event, protecting personnel and equipment. Regular maintenance and inspection of electrical equipment can help prevent faults and reduce the likelihood of arc flash incidents. This includes checking for loose connections, damaged insulation, and other potential problems. Proper grounding and bonding practices are essential for preventing ground faults, which can lead to arc flash events. This involves ensuring that all metallic components of the electrical system are properly grounded and bonded together. Proper labeling and signage are important for communicating arc flash hazards to workers. This includes posting warning signs at electrical equipment and providing clear instructions on how to work safely around energized equipment. Training and education are essential for ensuring that workers understand arc flash hazards and how to protect themselves. This includes providing training on the proper use of PPE, safe work practices, and emergency procedures. Safe work practices include de-energizing electrical equipment before working on it wherever possible, using insulated tools, maintaining a safe working distance, and wearing appropriate PPE. Arc flash studies are comprehensive analyses of electrical systems to determine the potential arc flash hazards at various locations. These studies typically involve collecting data on the electrical system, performing incident energy calculations, and developing arc flash hazard labels. Arc flash hazard labels provide information on the potential arc flash hazards at a specific location, including the incident energy level, working distance, and required PPE. These labels are typically affixed to electrical equipment and serve as a warning to workers. When incident energy is high, workers may need to use higher levels of PPE such as arc-rated suits, gloves, and face shields. Arc-rated clothing is designed to protect against the thermal effects of arc flash events. It is typically made from flame-resistant materials that can withstand high temperatures and prevent burn injuries. Arc-rated gloves provide protection against electrical shock and burns to the hands. They are typically made from leather or rubber and are tested to withstand specific voltage levels. Arc-rated face shields protect the face and eyes from the intense heat and light produced during arc flash events. They are typically made from polycarbonate or other impact-resistant materials. When working on or near energized equipment, it is important to use insulated tools to prevent electrical shock. Insulated tools are designed to withstand high voltages and prevent current from flowing through the user's body. Maintaining a safe working distance is another important safety precaution. The farther away a worker is from the arc flash, the lower the incident energy they will be exposed to. In addition to PPE and safe work practices, engineering controls can also be used to reduce arc flash hazards. These controls include arc-resistant switchgear, current-limiting devices, and zone-selective interlocking. Arc-resistant switchgear is designed to contain and redirect the energy released during an arc flash event, protecting personnel and equipment. Current-limiting devices such as fuses and circuit breakers can be used to reduce the magnitude and duration of fault currents, thereby lowering incident energy levels. Zone-selective interlocking is a protective relaying scheme that allows overcurrent protective devices to communicate with each other and coordinate their tripping times. This can help reduce the clearing time of faults and lower incident energy levels. Regular maintenance and inspection of electrical equipment can help prevent faults and reduce the likelihood of arc flash incidents. This includes checking for loose connections, damaged insulation, and other potential problems. Proper grounding and bonding practices are essential for preventing ground faults, which can lead to arc flash events. This involves ensuring that all metallic components of the electrical system are properly grounded and bonded together. Proper labeling and signage are important for communicating arc flash hazards to workers. This includes posting warning signs at electrical equipment and providing clear instructions on how to work safely around energized equipment. Training and education are essential for ensuring that workers understand arc flash hazards and how to protect themselves. This includes providing training on the proper use of PPE, safe work practices, and emergency procedures. The IEEE 1584 standard provides guidelines for performing arc flash hazard calculations. This standard includes equations and methods for calculating incident energy levels based on various factors such as the system voltage, fault current, and clearing time of overcurrent protective devices. The NFPA 70E standard provides requirements for electrical safety in the workplace. This standard includes guidelines for performing arc flash risk assessments, selecting appropriate PPE, and implementing safe work practices. Arc flash incidents can have serious consequences, including burn injuries, electrical shock, equipment damage, and facility downtime. By understanding arc flash hazards and implementing appropriate safety measures, these risks can be significantly reduced. Factors affecting incident energy include voltage, where higher voltage systems generally result in higher incident energy levels due to the increased potential for arc flash events and greater fault currents. Fault current is the amount of current that flows during a short circuit or fault condition. High fault currents lead to greater incident energy because more energy is released during the arc flash. Clearing time is the time it takes for the protective devices, such as circuit breakers or fuses, to interrupt the fault current. Shorter clearing times result in lower incident energy as the arc flash duration is reduced. Working distance is the distance between the worker and the potential arc flash source. Incident energy decreases with increasing distance as the energy dissipates over a larger area. Enclosure size and geometry affect the arc flash behavior and energy dissipation. Confined spaces can lead to high incident energy levels due to the reflection and concentration of energy. Electrode configuration, such as the arrangement and spacing of conductors, influences the arc flash characteristics. Different configurations can result in varying arc flash intensities and energy distribution. Grounding methods impact the magnitude and duration of fault currents. Solidly grounded systems typically have higher fault currents compared to impedance-grounded systems, potentially leading to higher incident energy. The type of overcurrent protection used, such as fuses or circuit breakers, affects the clearing time and the amount of energy released during an arc flash. Current-limiting devices can significantly reduce incident energy levels. PPE selection involves choosing appropriate protective equipment based on the calculated incident energy levels. PPE must be arc-rated to withstand the potential heat exposure from an arc flash. Arc-rated clothing, gloves, face shields, and other protective gear are essential for minimizing burn injuries. The hierarchy of controls prioritizes hazard elimination and risk reduction strategies. Elimination involves removing the hazard altogether, such as de-energizing equipment before working on it. Substitution replaces hazardous materials or processes with safer alternatives. Engineering controls involve implementing physical changes to the workplace to reduce arc flash risks. Administrative controls establish safe work practices and procedures to minimize exposure to arc flash hazards. PPE is the last line of defense and should be used in conjunction with other control measures. Regular inspections and maintenance of electrical equipment are crucial for preventing arc flash incidents. Identifying and addressing potential problems, such as loose connections, damaged insulation, and worn components, can reduce the risk of faults and arc flashes. Training programs should cover arc flash hazards, risk assessment, PPE selection, safe work practices, and emergency procedures. Employees should be trained to recognize arc flash hazards and understand the appropriate safety measures. Warning labels and signs should be prominently displayed on electrical equipment to alert workers to potential arc flash hazards. Labels should include information about the incident energy level, working distance, and required PPE. Coordination studies are performed to ensure that overcurrent protective devices are properly coordinated to minimize clearing times and reduce incident energy levels. Proper coordination helps prevent nuisance tripping and ensures that faults are cleared quickly. Ground fault protection systems detect and interrupt ground faults, which can lead to arc flash incidents. These systems help reduce the magnitude and duration of fault currents. Infrared thermography is used to detect hotspots and potential problems in electrical equipment. Regular thermographic inspections can help identify loose connections, overloaded circuits, and other issues that could lead to arc flash events. Power quality monitoring can help identify voltage sags, surges, and other power disturbances that could contribute to electrical faults. Addressing power quality issues can improve the reliability of the electrical system and reduce the risk of arc flash incidents. Remote operation of electrical equipment allows workers to operate switches, circuit breakers, and other devices from a safe distance, reducing their exposure to arc flash hazards. Arc flash relays are specialized protective relays that are designed to detect and interrupt arc flash events very quickly. These relays can significantly reduce incident energy levels. Fiber optic sensors can be used to detect the light produced during an arc flash event. These sensors can trigger protective devices to quickly interrupt the fault current. High resistance grounding limits the ground fault current, reducing the incident energy and potential damage. This method is often used in industrial and commercial power systems. Differential protection compares the current entering and leaving a protected zone. If a difference is detected, indicating a fault within the zone, the protection system quickly isolates the affected equipment. This method is particularly effective for protecting transformers and generators. Partial discharge testing detects insulation defects in electrical equipment before they lead to failures. This testing method helps identify and address potential problems early, preventing arc flash incidents. Online monitoring systems continuously monitor the condition of electrical equipment, providing real-time data on temperature, vibration, and other parameters. This allows for proactive maintenance and prevents equipment failures that could result in arc flash events. Routine testing of protective devices ensures that they are functioning properly and will operate as intended during a fault. This includes testing circuit breakers, relays, and fuses to verify their performance. Implementing a comprehensive arc flash safety program requires a commitment from management and the active participation of all employees. The program should be regularly reviewed and updated to ensure its effectiveness. The goal of an arc flash safety program is to protect workers from the hazards of arc flash and create a safe working environment. By implementing appropriate safety measures and following established guidelines, the risk of arc flash incidents can be significantly reduced. Regular safety audits can help identify areas where improvements can be made and ensure that the arc flash safety program is being followed. Audits should be conducted by qualified personnel who are familiar with arc flash hazards and safety requirements. A well-documented arc flash safety program provides clear guidelines and procedures for workers to follow. The documentation should be readily available and easily accessible to all employees. Emergency response plans should be developed and implemented to address arc flash incidents. These plans should include procedures for rescuing injured workers, extinguishing fires, and restoring power. Post-incident investigations should be conducted to determine the root cause of arc flash events. This information can be used to prevent similar incidents from occurring in the future. Continuous improvement is essential for maintaining an effective arc flash safety program. By regularly reviewing and updating the program, organizations can ensure that they are providing the best possible protection for their workers. The development of new technologies and safety practices is constantly evolving. Staying up to date with the latest advancements can help organizations improve their arc flash safety programs. Collaboration between industry, government, and research organizations is essential for advancing arc flash safety. Sharing information and best practices can help improve safety standards and reduce the risk of arc flash incidents. Public awareness campaigns can help educate workers and the general public about the hazards of arc flash and the importance of electrical safety. By raising awareness, we can create a safer environment for everyone. International standards such as IEC 61482 provide requirements for arc flash protective clothing and equipment. These standards help ensure that PPE meets the necessary performance criteria. National electrical codes, such as the NEC, provide requirements for electrical installations and safety practices. Compliance with these codes is essential for preventing arc flash incidents. Local regulations may also apply to electrical safety. Organizations should be aware of and comply with all applicable regulations. Consulting with qualified electrical engineers and safety professionals can help organizations develop and implement effective arc flash safety programs. These experts can provide guidance on risk assessment, PPE selection, and safe work practices. The use of technology, such as augmented reality and virtual reality, can enhance arc flash training and education. These tools can provide realistic simulations of arc flash events, allowing workers to practice safe work practices in a safe environment. Data analysis can be used to identify trends and patterns related to arc flash incidents. This information can be used to improve safety programs and prevent future incidents. The integration of arc flash safety into overall safety management systems can help ensure that electrical safety is a priority. This includes incorporating arc flash safety into hazard assessments, training programs, and emergency response plans. The use of drones for inspecting electrical equipment can reduce the risk of arc flash incidents. Drones can be used to inspect overhead power lines, substations, and other equipment from a safe distance. The development of new arc flash detection and mitigation technologies is ongoing. These technologies have the potential to significantly reduce the risk of arc flash incidents. The standardization of arc flash safety practices across industries can help ensure that workers are protected regardless of their employer or location. This includes promoting the adoption of best practices and the use of standardized PPE. Continuous monitoring of electrical systems can provide early warning of potential problems that could lead to arc flash incidents. This allows for proactive maintenance and prevents equipment failures. The use of predictive maintenance techniques can help identify and address potential problems before they lead to arc flash incidents. This includes using vibration analysis, oil analysis, and other methods to assess the condition of electrical equipment. The development of more arc-resistant materials and equipment can help reduce the severity of arc flash incidents. This includes using materials that are less likely to ignite or melt during an arc flash event. The use of smart PPE can provide real-time monitoring of a worker's exposure to arc flash hazards. This allows for proactive measures to be taken to reduce the risk of injury. The integration of arc flash safety into the design of electrical systems can help prevent arc flash incidents. This includes using arc-resistant equipment, minimizing fault currents, and providing adequate working clearances. The use of distributed generation and microgrids can impact arc flash hazards. It is important to consider these factors when performing arc flash risk assessments. The use of energy storage systems can also impact arc flash hazards. It is important to consider these factors when performing arc flash risk assessments. The use of electric vehicles and charging infrastructure can introduce new arc flash hazards. It is important to be aware of these hazards and take appropriate safety precautions. The development of new standards and regulations related to arc flash safety is ongoing. It is important to stay up to date with the latest requirements. The sharing of information and best practices between organizations is essential for improving arc flash safety. This includes participating in industry forums and attending conferences. The promotion of a culture of safety is essential for preventing arc flash incidents. This includes empowering workers to speak up about safety concerns and rewarding safe behavior. The recognition of employees who go above and beyond to promote arc flash safety can help reinforce the importance of safety. This includes recognizing employees who identify potential hazards, implement safety improvements, and promote safe work practices. The use of checklists can help ensure that all necessary safety precautions are taken before working on or near energized equipment. Checklists should be tailored to the specific task and equipment being worked on. The development of job hazard analyses can help identify potential arc flash hazards and determine the appropriate safety measures to be taken. Job hazard analyses should be performed for all tasks that involve working on or near energized equipment. The use of lockout-tagout procedures is essential for de-energizing electrical equipment before working on it. Lockout-tagout procedures ensure that equipment is properly isolated and cannot be accidentally energized. The use of personal protective grounds can help protect workers from electrical shock during arc flash events. Personal protective grounds provide a low-impedance path to ground, diverting fault current away from the worker. The use of voltage detectors can help verify that electrical equipment is de-energized before working on it. Voltage detectors should be used to test each conductor before touching it. The use of arc flash curtains can help contain the energy released during an arc flash event, protecting personnel and equipment. Arc flash curtains are typically made from flame-resistant materials and are designed to withstand high temperatures. The use of arc flash blankets can help protect workers from the thermal effects of arc flash events. Arc flash blankets are typically made from flame-resistant materials and are designed to provide insulation from heat. The use of arc flash suits can provide full body protection from the thermal effects of arc flash events. Arc flash suits are typically made from multiple layers of flame-resistant materials and are designed to provide protection against specific incident energy levels. The use of arc flash gloves can provide protection to the hands from electrical shock and burns. Arc flash gloves are typically made from leather or rubber and are tested to withstand specific voltage levels. The use of arc flash face shields can provide protection to the face and eyes from the intense heat and light produced during arc flash events. Arc flash face shields are typically made from polycarbonate or other impact-resistant materials. The use of arc flash hard hats can provide protection to the head from impact and electrical shock. Arc flash hard hats are typically made from non-conductive materials and are designed to provide protection against specific voltage levels.